So, I've meant to shift the slide out. Nomenclature, if you need help, go to the Tutoring Center for rules. Your lab manual, as you will find out today and on Thursday's lab, is full of nomenclature examples. We'll be doing tons of those. Okay? Lab number 7 is also Lewis structures. Those of you being, bless you, that thinking that you didn't have to worry about Lewis structure after the first exam, it is going to show up in the second exam. Okay? Remember how I yelled and screamed and freaked out about Lewis structure? Because I don't like how anybody else teaches it, and it bothers me so much. Okay? It bothers me enough that I'm going to make sure you know how to do it by testing you on it again and again and again. Okay? So it is going to show up again. Okay? So, metric system. Dang it, we talked about this, didn't we? Yeah. This is an issue with these slides. When we talked about kilo centimilli? Yep. Yeah, and so you know those? Okay. Yep. Yep, it's the copy thing. No. 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 There we go. So, mass in grams of a 325 milligram aspirin tablet. Right? So again, we want the process behind this. What am I trying to get? Grams. Grams. Officially, grams of aspirin. Okay. What am I starting with? Milligrams. Milligrams of an aspirin tablet, and it's 325. So I've done step 1 and step 2. Are milligrams of aspirin the same thing as grams of aspirin? No. Are they related? Yes. Yes. Okay, but they are not the same. Okay, because they are not the same, I have to include a conversion factor. Okay. The whole point of this setup is that now I don't care about what that relationship is yet. I want to focus on, is there a relationship? Okay, what do I ideally want? Okay. That's going to dictate the units that go into this. Okay. Well, which are you more concerned about? What you're starting with or what you're ending with? Okay. We're hearing a lot of people saying what you're ending with. Okay, so I want to put what I'm ending with. What am I ending with? Grams of aspirin. Where? In the numerator. So in my conversion factor, where should grams of aspirin show up? In the numerator. Because then it's in the numerator on both the left and right hand side of the equation. Make sense? Okay, so cool. You've brought that in. Okay. So that's now helpful. Okay, but if I just did the calculation as shown, would I have just grams of aspirin for my answer? No, I'd have milligrams times grams. Well, that doesn't work. So what has to happen? I need the milligram of aspirin to cancel. So I can place my milligram of aspirin where?
In the denominator.
In the denominator, so that now that unit can cancel out. Right? Now I would have grams of aspirin. And then this would go to Ryland's suggestion. Do I know this conversion factor? Okay. This is a power of 10 conversion. You're required to know this. You are required to know that milli means
thousands place.
That's fun. Okay. So let's backtrack a little bit. You are required to know that milli means
Thousands place.
10 to the negative third. For those of you saying thousandths place, okay? Talk to the people around you. When you say thousandths, are you saying thousand or thousandths?
Thousands.
Okay. It can be really hard to hear that TH. So maybe we shouldn't be saying it as the term, but going back to the power of 10. 10 to the negative third. Red. It can be applied to stoichiometry. Stoichiometry is looking very particularly at chemical reactions, which we haven't done yet. Okay. This is the setup for getting to stoichiometry. Whoops. So if we wrote all that work out, grams of aspirin, 325 milligrams of aspirin. We had our conversion, milligrams, aspirin, grams of aspirin. What did we say milli was?
1 times 10 to the negative third.
10 to the negative third. Now I don't have to worry about that sound, it's 10 to the negative third. It's a lot easier to translate that. The power of 10 is associated with which unit? Milligram or gram? Gram. The power of 10 is always associated with the core unit. Which is the core unit? Grams or milligrams? Grams, because it shows up as a core in both names. So I can drop my 10 to the negative 3, my power of 10 in front of grams. I put a 1 underneath. Why 1 and not some other number?
Because if you convert it, it's equal to 1.
So we could go back to the equation to do that conversion. Okay, we know milli meant 10 to the negative 3. That was what that meant, the number. If I make that 1 anything other than 1, is it 10 to the negative 3 anymore? No. 1 is the only value I can put in there that maintains the meaning of 10 to the negative 3. Okay? That is now my conversion factor. What happens to my units? The milligrams cancel. I'd be left with grams of aspirin. All I have to do now is enter it into the calculator, and my calculator spits out an answer that is correct. Okay? Make sense?
Yes.
Okay. So let's level it up in difficulty. What is the mass in micrograms of a 325 milligram aspirin tablet? Okay. So with that question, I see everybody starting to frantically start to work. That's useful. Okay. Well, we're going to run into an issue. An issue? An issue? Are you required to know what micro means? No. So what would you do if this was on the exam?
Go back to the first page.
Go back to the first page, and on the first page, it says that micro is the mu symbol, and it equals 10 to the negative 6. Okay. You now have all of the information in theory to solve the question. Go through and solve. Where do we start? What are we ending with? I want micrograms. It's that goofy cursive M, if you want to call it that, but it's really the mu symbol, right? Greek letter. I want micrograms officially of the aspirin, but I'm going to be lazy and just ignore the aspirin. What am I starting with? Milligrams of the aspirin, 325 milligrams. In the ideal world, well, actually, the first question is milligrams the same thing as micrograms? No. So I need a conversion factor. In the ideal world, milligrams would show up in the denominator so that the units cancel, right? So I'm looking at it now from the perspective of I want to get rid of milligrams. Okay, so I'm going to put in the milligrams on the bottom. In the ideal world, micrograms shows up on top, right? Do we know that conversion factor? Okay. I'm really glad that most of you shook your head no. Some of you shook your head yes, because you're good at doing the powers of 10 shuffle, and in that dance, that's awesome. You are probably right 60% of the time. 40% of the time, you're wrong. The issue with that is not passing. Right? So what I want is a process that consistently works. We don't have that conversion factor. Right? Which means I need a new conversion factor. You all said in the last question that you liked going with where you were ending. So I'm going to keep microgram, and I'm going to get rid of milligram. I want a different unit for the milligram. What can I convert microgram to? Okay. I'm given a conversion up the top. I can go to grams. Okay. What is the relationship between micrograms and grams? 10 to the negative 6 is the meaning of micro. Where does the power of 10 go? With the core unit. Which is the core unit? Micrograms or grams? Grams, which means 10 to the negative 6 goes on the bottom. What goes on the top? 1, because otherwise it's not 10 to the negative 6. So our power of 10 does not always go on top. It does not always go on the bottom. It goes always with the core unit, wherever that core unit may be placed. Kind of make sense? the next part. Okay. What would my answer be in units? So just the units if I ran just that calculation. It would not be micrograms. It would not be grams.
What's the question?
Okay. If I run just the calculation shown here, what is the unit for my answer? Okay.
Grams of
Well, does the grams cancel?
No.
No. Does the milligrams cancel?
No.
No. Does the micrograms cancel?
Milligrams
No.
of grams.
So what is my unit? Milligrams times micrograms divided by grams. That would be my unit. That is an ugly, horrible, awful unit. It is now a massive, complex unit. Okay? This is one of the reasons why most people, when they solve, don't solve for what you're trying to get to in the first step. They solve by trying to simplify and get rid of units. All right? We'll look at that in just a second. So we have this ugly now system of units. We at least got micrograms back. What do I need to get rid of? Milligrams. Where does milligrams need to show up in my new conversion factor? Why does it need to show up on the bottom? So that it cancels the one on top. Okay? That's just awkward. What do you mean that's just awkward?
Oh, no, I'm saying what you said. You just said, like, oh, just that's how it works. I was
Oh.
thinking about that.
Oh, okay, well then never mind. And we won't work with that yet. Okay? What needs to show up on top? Grams. Why does grams need to show up on top? So it can cancel the one that's on the bottom. Okay? It's not just necessarily how it works. Okay? It's because these units cancel. Which now if I run my calculation, what's the only unit remaining? Micrograms. Before I can run the calculation, I have to make sure I've got the numerical values inserted into my conversion. I did it for the microgram to gram. I didn't do it for the milligram to gram. What does milli mean? 10 to the negative third. Where does the power of 10 go? Okay. With the core unit is our grams. 1. Now all I have to do is enter it into the calculator. My calculator spits out the answer, and I'm done. Kind of make sense? Okay. So, are there other ways of setting this up? Yes. Let's just track the units. If I had milligrams and I wanted micrograms at the end, okay, one method says, well, like we showed at the bottom, I want micrograms, so I'm going to start getting micrograms into my equation as soon as possible. Okay? But that gave us this weird, goofy unit at the end of that calculation. So instead of going directly to micrograms, I'm going to get rid of the milligrams. So I can put milligrams on the bottom. But what can I convert milligrams to? Grams. Okay? That now simplifies the unit. I'm getting rid of one of my units as I move through this. Okay? That gram is not microgram, so now I can do gram, microgram. What is the conversion between microgram and gram? That's one again I know. The grams units cancel and I'd have micrograms in my answer. So depending on which method I prefer, I can organize these in a different sequence. Why can I organize that calculation in a different sequence? Why am I allowed to do that?
Because either way you look at it, you're canceling out the units.
Kind of has to do with looking at the units. There's another thing. What's the mathematical operation being run? It's multiplication and division multiplication and division are a fancy word in mathematics. What's that? Not reciprocal. Communicative? Meaning the order in which we run those calculations doesn't matter. Okay? So I can insert my conversion factors at any individual sequence.
It doesn't do multiplication first?
It doesn't. It's whichever one shows up first.
Graphing calculator doesn't do first. Multiplication.
It's whichever one shows up first.
Yeah. Okay.
Yeah. Okay? Does that make sense? So we have our process established. The order in which we insert those comes down to what we see first. In this case, we only had 2 conversions. It's not that big of a deal. We'll either do one first or the other. We're still going to get the same result. This is technically two conversions either way. Okay? There are other methods where you go through and solve for, say, grams first, and then convert grams into micrograms. Okay? That is now two calculations with two equalities, which means you have twice the opportunity for making a typo when you write down your work. If you do it as a single line, you've now inserted all of those conversions into one massive thing. You only have one chance of screwing that up as opposed to two. Okay? So this single line format can simplify your conversions and help minimize mistakes. Okay? If you're used to going through and solving algebra equations to do it, by all means go ahead and do so. But when you have to string together 5 conversions, the odds that you screw up any one of those algebra expressions becomes astronomically high. Okay? So the whole point of this is to simplify and keep it as organized as possible. Okay? The next thing, because someone was actually going to do a topic about this. Okay? You heard of the King George hates
Yeah.
vanilla ice cream, so punches dogs or whatever it is? I don't know what the stupid sequence
What is
is.
it for?
It's a mnemonic device to memorize the powers of 10, those
Yeah.
prefixes. Okay. And people will often use, particularly in math classes, use that a way of shifting the decimal. So this is something that you were mentioning, Rylan. Which way do you shift the decimal? Is it bigger or smaller? This method removes bigger or smaller. It's not there. I don't have to worry about shifting the decimal. The calculation does all of the shifting of the decimal for me. Okay? So that whole King, Henry, George, whatever the heck it is, I find to be absolutely abhorrent. Okay? Because it tends to put out a crutch and say, well, I have to know this bigger, smaller thing. So you're memorizing more things as opposed to just saying, what's the value? If you use it to memorize just what the value is, by all means, go ahead. Awesome, fantastic, that works. Kinda, sorta?
Yeah.
Okay.
Could you flash back to that one page with the kilo just for a second?
Okay. So our power is 10. How does King George even fit into this? Isn't it King George?
King Henry died, what you know what you're talking about.
There you go.
Oh, because yours doesn't have hecta and all that.
Yeah.
And deca.
So there you go.
Bad luck drinking chocolate.
So, what? Another what? King George?
Another measure?
Oh, another conversion. Funny you asked. Let's give that a shot. Let's see. Do I have another conversion lined up? Oh, snap, I do. Look at that. Okay, except, okay, the powers of 10 conversion, relatively straightforward. Okay, a lot of those you can internalize. In fact, most people do internalize those conversions. Okay, again, I'm fine with you internalizing it. Make sure that your internalized answer matches the method that you're solving with. That's all you're trying to do here, is get that method, that process built so that you can be consistent in it. Okay. What we now start to scale up to is that not everything is a power of 10. When we convert between English and metric, we now have this added bonus of not being powers of 10. 1 inch is 2.54 centimeters. That's not a power of 10. It's not even a power of 2.54. Okay? Mass, 1 pound, 454 grams. 1 quart, 946 milliliters. 1 second, thankfully, is 1 second. They're kind of dicks on that one. Why is that one a bit of a problem?
But it's significant like figures. So.
Ah, okay, so I didn't say it. Lauren said it. It's her fault. We have to worry about sig figs.
Sorry.
Okay? And that last one, you're saying, oh, well, those zeros are now significant figures. And yet, when they write out the 1 sec, what did they do? They didn't show those significant figures. They should have shown them. Okay, not only that, but then they're making it look like there's 2 different unit systems for seconds. There's sec, S-E-C, versus S. No, there's 1 unit for time. It's seconds, abbreviated S. Why they're going through and saying that the English version has SEC is a complete nonsense. Okay? So it's just second. So in that last one, you might say, well, there's 3 sig figs. Well, is it really? 1 second equals 1 second. That's the only 3 significant figures? This 1 pen equals 1 pen. How many significant figures in that?
Infinite, sorry.
It is now infinite. There is exactly 1 pen. Not 1.1 pens. Okay, not 2 pens. There's exactly 1 pen. 1 second is exactly 1 second. There isn't a conversion there. They're the same thing. What happens when we move up to quart versus milliliters?
Is that exact or is it 3 significant figures?
I don't know. Is it exact? Is it not? Turns out it is not exact. Okay? That conversion factor actually has 3 sig figs because of the 946. But then, of course, you might say, well, shouldn't that 1 actually be 1.00? Yes. Yes, it should. And they screwed that up when they wrote it. Okay? This is, again, back to that reason why I said sig figs can be a bit of a pain and we're not consistent in how we apply it. Okay? What happens if I run a calculation in a conversion between quarts and milliliters? Are they milliliters? Yeah. Okay, where I want 4 significant figures. How do I get 4 significant figures? Because in this conversion, it would drop to 3. Okay? One suggestion is, well, just add an extra 0. But is that actually true for this conversion? No. So what would we have to do? You have to look it up. You'd have to find the new conversion factor that's now 4 sig figs. What if you wanted 5 sig figs? You look it up to get 5 sig figs. Okay, 6, and so on. So we end up inserting conversion factors that have the proper amount of sig figs so that we do not lose significant figures in our calculation. Okay? For this class, nearly everything we deal with is in 3 sig figs, so they can get away with just showing it as 946 and not worry about the rest of those sig figs. Same deal happens for pounds to grams. Okay? That's really 1.00 pounds is 454 grams. If I want another sig fig, I have to look up a new conversion, factor, and it's 4.54.3. Okay? So there's an extra sig fig. What happens when I move to inches and centimeters? We might say the same thing.
You need to have 3 sig figs.
Okay? Except let's think about when we do these conversions. Okay? If I'm going to build something, what am I going to measure?
Inches.
Which is a measure of
Length.
length. Okay? How often do we build things in society?
Every day.
Pretty often. So the length measurement gets used a lot. When I go through to build something, do I really care about the mass?
Yeah.
Kinda. But the length one is going to be more important. Okay? Same deal with volume, same thing with time. So the length one is one that is now consistently used across the world at all times. Which means I'm going to be doing this conversion a lot. Which also means I have to be concerned about how to do that conversion a lot. And I have to be concerned about the sig figs a lot. So somebody comes along and says, I'm tired of being concerned about it. I'm going to agree that you will disagree with me and we will never use the same system. I'm stuck in inches, you're stuck in centimeters. We're not going to change. But let's agree to disagree in such a way where we have to stop worrying about sig figs. How do we do that? We can.
Choose which system you're going to use when building something.
No, because that means one of us has to lose out. We will both agree that 1 inch is now defined as 2.54 centimeters. Okay? All measurement systems are human inventions. So when I'm now converting between human inventions, can I establish my own convention for that conversion? Absolutely.
Could you make it like 1 inch is 5 centimeters?
I could agree to make that definition. Exactly right. Okay. That will change the meaning of those. Okay. And historically that becomes a problem. Okay. But I could go through and do that. Okay. Okay? Because it is now a definition, how many significant figures are in the conversion between inches and centimeters? It is now an infinite number of sig figs. If I scale up to 4 or 5 sig figs, the 1 inch to 2.54 does not affect my answer because that one is a definition. Okay? How would we know that by looking at this figure? We probably wouldn't because some jerk went through and erased the footnotes. And if we unhide those footnotes, we find out that 1 inch has been defined to be exactly 2.54 centimeters, which means we have an infinite number of sig figs in that. Okay? So it's important to think about our sig figs as we approach this. Okay? So now let's move into actual practice with the conversion, because that's what Nicole wanted. And I just do what you guys ask. Okay? The length of an American football field, including the end zones, is 120 yards. I want to know the length in centimeters. Okay? You now have the context to set this up. So let's go ahead and real quickly provide the answers to the easy stuff. Step 1, this equals centimeters. Step 2, 120 yards. Step 3, in the ideal world, yards would be on the bottom, and the ideal centimeters would be on top. Now I just got to plug in the values for that conversion factor. Do I have that conversion factor? No. Okay. Since I don't have that conversion factor, I now have to decide what I want to convert it to. Okay. Based off of kind of that last example, I kind of got the feeling that most people like the idea of canceling yards. Yeah? So here's your start. Pick something to convert those yards to. Continue to process out until you're at centimeters. If you have questions, raise your hand, talk to the people around you, raise your hand, talk to me. I'll come around and look at your answer. This class was not consistent in how it was solved, so that was kind of interesting. Okay. The other class that I teach for the 130, roughly half the class, or all the class did one method. But not the other. So they were really confused because then I could go through and say, well, you were all wrong, this is the answer. And they're like, what the heck? How did that work? So this isn't going to work out quite so nicely. Okay? So yards, canceled. I need to convert the yards into something. Okay? So I'm hearing a suggestion to go to meters. So let's go ahead and do it. Okay? I have that conversion right here. Right?
Yeah.
Okay? I know 1 yard is equal to 0.914 meters. Where does the 1 show up? Okay. Anybody saying on the bottom or on the denominator, I am sorry, you are wrong. If you said the numerator, you are twice as wrong.
That's why I didn't say anything.
Where does the 1 show up? Not with the core unit, but that's getting at the right idea.
Is it the start?
But 1 yard equals 0.9.
You're starting to get at the right idea. Where does the 1 show up? Nope. I do not accept bottom as an answer. Next to yards. Okay? You didn't say it loud enough. Okay? And that is a very subtle difference in how we're referencing this. But if we go through and say the 1 shows up on the bottom, guess what happens the next time you do this conversion? And we swap the units. Where do you end up placing the 1?
Probably on the bottom.
On the bottom. The 1 doesn't belong with the bottom. The 1 belongs with yards. Yards happens to be on the bottom. That's why the 1 goes there.
I messed up on 2.
It is a very subtle difference in how we approach this, but that difference is huge when it comes to actually solving this. Okay? And you may be like, that's nuts, that's stupid, I shouldn't have to do that. I'm sorry, you will get it wrong for probably that reason. Because you'll be like, oh, the 1 belongs on the bottom. No, the 1 belongs with yards. I know what you might have been trying to say, you didn't say it. What shows up in front of meters? 0.914.
I'm the one that got us to the solution. So
Okay. So are meters the same thing as centimeters? No, which means?
They're related.
Okay, they're related.
Yeah.
So I can put meters on the bottom. Why would I put meters on the bottom?
cancel out.
Yes.
So that it can cancel. And ideally I would have centimeters on the top, right?
Yes.
Okay. Do I have that conversion?
Yes.
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 We're supposed to know.
You were supposed to memorize that centi is
Negative 10 to the negative
10 to the negative 2. Yes. The power of 10 goes where? With the core unit. The core unit in this case is meters. I would place the power of 2, power of 10 on the bottom. Place the 1 on top. And I now go through and solve. Okay. A lot of it comes back to the meaning of how we establish this and where we put those numbers in. Could you have put in 100 centimeters as 1 meter? Yes, absolutely. You've added an extra layer of interpretation into your memorization. If you miss that you've added that extra layer of interpretation, which is very common, you will screw up other conversions. Okay? So what I'm trying to do is remove the interpretation and only stick with the memorization. We just apply the rote memorization and we're good. Okay? 100 over 1 still counts as a valid solve.
On the exams, are you going to have something nice like all of these equivalents?
On the exams, will I give you all these conversions?
Probably not.
Who of you looked at the very first page of the exam?
We have all of them.
You have all of those
It
conversions
it
given to you.
applies to like
Okay. I won't apply it immediately with the question because I want you to actually have to think about it a little bit. Okay? Because if I provide it, then everybody just uses whatever's there. Okay? Which is actually kind of the trap I put up here too. Okay? So, a couple people went through and solved it this way. What did you get for an answer? 10,968. Did everybody get 10,968?
I didn't. I did it wrong.
What did you get for unit? I've already got centimeters floating out there.
I got 10,972.87.
I got 10,972. What'd you get, Lauren?
No, that's what I got.
10,972. I've got two people saying 10,972.
10,968.
Okay, we got another 968. Anybody else have a 7.2 or a 6.8? 10.9. You got a 68? We got two people here that weren't speaking up for 7.2.
Did you guys use your parentheses correctly? I didn't have any.
You got a 7.2. This is interesting. Our class is roughly split. Half the class says 10.968. Half the class says 10.972. For the half the class that said 10.972, did you solve it the way that is shown up here?
No.
No. What did you do?
I first put 3 feet over 1 yard.
Is that a valid conversion? Okay. Just checking.
And then I put 30.48 centimeters over.
Okay, I don't want yours.
I
Sorry.
know, mine was the weird one. Like,
I did the same thing, and then I went 12 inches over 1 foot, and then 2.54 or centimeters over 1 inch.
Right? Inches cancel. Feet cancel. Yards cancel. What would we have for a unit as an answer? Centimeters. We enter that into the calculator and we get 10,900 and go away. Sorry, my computer froze up. 10,972 and centimeters. I don't want to deal with 0.8. Who's right?
Both of us.
You're both right.
you both do it?
Just us.
How can you both be right? This is the issue with English to metric conversions. Okay? They're not exact. Okay? Depending on which conversion factor you use, where you're doing your English to metric conversion, you will generate a drift in your answer. That drift is noticeable in the final answer. 10,968 versus 10,972. Okay? Well, that sucks. Okay, it's multiple choice. Both these answers show up in your multiple choice. God, what a jerk.
Choose
have like
E,
a-
which is
like
like
you're gonna have one of those
AP
questions where it's like
answer.
both B and C or something like that.
Neither of these answers is correct.
Great. Sig figs.
One, two, zero is not significant. I can only have 2 sig figs in my answers. Both those answers have well more than 2 sig figs. So I have to go back through. I can only report out to the, what is that, thousands place for my final answer.
11,000.
Because the 9 is larger than 5, I have to add 1, and this becomes 11,000
That's what I got.
centimeters.
I just decided not to say it.
Wait, hold on, you said there's only 2 significant figures in this?
There are only 2 significant figures because of the 120 yards from the very beginning. Okay? Yeah. This whole time it was a freaking trap. Exactly. Okay? That's the way I set things up. Okay?
It's like Star Wars.
So, when we go through and evaluate this question, if we were looking at a straight multiple choice, you would see all 3 of these answers. Right? If you saw all 3 of those answers, you should immediately say, well, I don't have to do the conversion. Because this now goes back to sig figs. The only difference between those is sig figs. All I have to do is look at the 120 yards, say it's 2 sig figs. All 3 of those answers zero in on the 11,000. 11,000 is my answer. There's no calculation. That's not fair. What do you mean it's not fair? You read the question carefully and acknowledged that based on the information given, the only thing being asked for was sig figs. You answered what the question was asking for, only sig figs. The calculation, you might say, well, oh, I did all that work and I'm not getting any credit for it. You're getting credit for analyzing what the question's asking, which in this case is sig figs. Okay? That's a lot of work for me to be like, nope, I don't even want to evaluate. Particularly to hide the sig figs behind it. That's kind of me. So where would I ask this question so that I could get at you showing me the work and asking sig figs? Free response. Because in the free response, I'll grade you based off of the work and the answer. Right. And if you look at the practice exam, guess where this question has shown up in the past? In the free response, for that exact reason. It's the only way I can ask a sig fig question and dig at conversions or a more complex question is if it's showing work. Otherwise, when it shows up in the multiple choice, you're right. I could embed tons of calculations into it, and none of those calculations are relevant because they all boil down to the sig figs. Okay? Is that a depressingly good thing?
I'm still kind of confused how this question.
It's just
the
depressing.
idea that you want to sig figs pocket.
Okay. When we go through and look at our answer, okay, that comes back to multiple choice. If it was a multiple choice test, that's how we would know it's only looking at sig figs.
Oh, okay.
Okay. If it's a show your work, you have to show your work. Sig figs isn't necessarily part of it. Right? It plays a small contributing factor because you'd have to show all the other work.
Could you walk just one more time? I'm sorry, that quick calculation that you did to find. We did all this work, but you were able to like determine based on just the 120 yards that it would be 11,000 centimeters. How did you get that real quick?
Yep. How do we get to 11,000? 120 yards has how many sig figs? 2. Which means my answer can have 2 sig figs. Take a look at 10,968. 10,000. 1,000. That's a 0. But because that's 9, I can add 1. This becomes 11,000. Those zeros are now not significant because I haven't put a decimal point.
So if there's like a 13,000 up there too, that could be an answer.
13,000 could possibly also show up. That is now even further off base because that doesn't round out.
So you would have to do the equation.
You would still have to do the work.
You could theoretically have to go through and do the work then, yeah. Why I chose meters?
I'm spreading the wrong number.
So between those two conversions, why did I choose one versus the other?
One of them's more condensed, the other just is.
So when you went through and solved this one, you were like, yeah, one method is going to take a lot more conversion, so I'm not going to do that one, I'm going to do the other one.
That's what I thought.
No, I just went with what my brain right field is easier.
I would make the argument that you did not know when you started this that one was going to take 3 conversions and one was going to take 2. Okay? I would bet very few people knew that.
I actually knew that just because I can tell by...
That's fine. So you were able to process that out. Most people, I would argue, can't. Okay? So how would we decide if you are one of those people that can't? Which answer is right?
Let's give it.
They're both right. It doesn't matter which one you use.
There are no wrong
And
answers.
now you're saying that there's a different meters that you're talking about? Why do meters over yards as opposed to yards into feet? I had that conversion. Okay. Why did I convert yards to feet? Because? Oh, okay. Oh, for that one? Yeah.
Use our right to not answer.
Okay. So, with that, I think what you're getting bogged down in is trying to get an answer. Okay, so let's pause and recollect here. Okay. Answers are not what you're trying to get. The whole point of this unit is to get what? The process. Is your process correct? Yes. Stress less about the answers. The final formal answer has to consider sig figs, so you'll have to do that after you do your calculation. Dominic, and then... Okay. Why did I not write 10,900 for my final answer? 3 sig figs, not 2. So you still have to be able to interpret sig figs. If this question showed up on the test in the show your work and all of your work was perfect but you boxed the wrong answer, would you get credit?
Yeah.
Yes. Because it's to show your work. Is your work correct? Yes. You missed one aspect of that, the final rounding of your sig figs. You get most of the credit. Okay, in a 5-point question, if you wrote 10,968, you got 4 out of 5 points. If this is actually multiple choice, it's now 0. Okay, so it depends on where the question is asked. Okay, and with that, we're moving forward. You can talk to me after class. So, we've seen conversions like this. Okay, Harry has 100 pennies, Douglas has $3 bills, Sally has whatever that is, 30 dimes. Right? You've been in a math class where they give you these word problems, and all these word problems. Or you've seen Harry's taller than Sally, Sally's shorter than Timmy, Timmy's taller than Jerry. What's Jerry's height relative to Harry? Okay, those super exciting things. You're like, why would anybody do that? Right? You just look at them, and you're taller, you're shorter. There, it's done. Okay. Why do we have these stupid kind of questions in math class? Everyone goes, oh, I would never need this. To build the process so that when some jerk-off in chemistry comes along and changes the units to something that you have no mental capacity to understand, you can still do the conversion factor. That's where it's coming from. Does anybody know what a skittle fart is? Okay, no. Snorlaxy? What? Yeah, who knows? But can we still solve the question? This is where our process comes into play. What are we trying to get? I want skittle farts. What am I starting with?
Snorlaxy.
I'm starting with Harry. What does Harry have? Oh, he has Snorlaxy. You're right. How many Snorlaxy does he have? 100. Harry's on drugs? Are Snorlaxy the same thing as skittle farts? No. So I have to establish a conversion factor. Snorlaxy, ideally into skittle farts. Do I have that conversion? No. So what do I have to do? Snorlaxy into the only thing I can convert into, which is dimes. Okay. I know that 8 dimes happen to equal 10 Snorlaxi. Okay? Dimes are not Skittle farts, so what do I have to do? Get rid of dimes, and I got to get my Skittle farts back in. What is the conversion between dimes and Skittle farts? 3 dimes, 1 Skittle fart. What happens with our units? Snorlaxi cancels, dimes cancel. We now enter it into our calculator, and what do we have? Skittle farts, our question is solved. Do I know what a Skittle fart is?
No.
No. Do I know what a Snorlaxi is?
No.
No. But I know I have a conversion factor. I have that numerical. We don't know it's money. These could be toys.
Oh, they just have that value?
These could be ideas. We have no concept of what those things are. Okay? So what we're trying to do within this section is develop a process to establish these conversions so that you can do calculations with things that you don't understand. Once you've started to work with the conversions, you can now start to build in that process of what does that mean. The meaning will come later, largely because meaning is a more difficult concept. Okay? This is why we have crazy gurus at the end of their life saying they have discovered the meaning of life. We don't have a 5-year-old being like, I've discovered the meaning of life. Because meaning is a hard thing to determine. It takes time and practice. Okay? That's why we have to have a conversion factor to allow us to manipulate these complex concepts in the hope that eventually we can build the meaning behind those concepts. Okay? That's again the point of this unit. Okay? Build the process and hope the meaning comes. Okay? Little country ball commercial here, I guess, if we will. This is based off a true story. The U.S. sees a tank that the French built. Said, that's kind of a cool tank. I got an opportunity to make money. So I'm going to go to the French and say, hey, I will build that tank for you. Just give me all your plans. I'll build the tank, sell the tanks to you real cheap. Okay? I just have to be able to build them. 5,000 inches long? That's a really big tank. It didn't look that big to me. Okay? Well, that's because it's not 5,000 inches. It's 5,000 millimeters. Oh, that's a little bit different. Right? What does the U.S. say? Well, do you actually have this plans to build the tank in imperial units, which is known as our English units? No, we don't. We just have the, the normal real unit system. Oh, well, never mind. I don't need to make the money anyway, and the U.S. walks away. Literally what happened. Yeah. Pretty awesome. Right? All because of that unit conversion. And you might say, well, can't they convert the units? Can you convert inches to centimeters? Yes. You have a wrench that is now measured for the metric system. Can you convert that metric wrench into English or the American system? No, not without remachining that tool. Okay? All of the tools and the equipments to build everything, we don't have the capacity for. We'd have to build a whole new system for it. That's why we don't do the conversion. Okay?
So do we make American products when we did so?
Yeah, there's all sorts of issues between cross-communication products.
On my car because it's German, like I have to get all kinds of special tools and shit.
Exactly right. Okay, so compound units.
Yeah, it does. It's really
Okay? We're looking at compound units. What are the units for speed on your car, bike, walking to class?
miles per hour.
Miles per hour. You'd almost always see that written, or you actually probably see that written as MPH. Okay? You might see that written MI for miles/hour. I would argue both of those are not useful. What unit is in the numerator? Okay. I just heard 3 different answers, and one of them was a sigh. Okay? That's a bit of a problem. What if I write miles per hour? Which unit is in the numerator?
Miles.
Okay? If we write it in the fractional notation, it becomes very apparent where our units are located. It can allow us to solve our questions much more quickly and efficiently. So always write them out in the fractional notation. not in these stupid slash ones. Why do we have the slash notation?
So it fits even.
Typewriters.
Sure, blame the writing technology. No, that's exactly what it is.
That's exactly what it is, typewriters. Because how easy is it to type out miles and then on the next line write hours underneath it? For a typewriter, it's a pain in the butt. Okay? Which is why they said, well, let's just say a slash and now it'll fix everything. Now it's all on the same line. It's a technological reason behind the failure. Okay? That means you have to convert the technology in your head. Okay? So immediately put it into the fractional notation. That minimizes things. The next part of this, okay, let's pick something we can work with. How about 105 kilometers per hour? Okay, how can we set this up? So motorcycle traveling at 105 kilometers per hour. I want the speed in meters per second. So to solve equals,
Meters per second.
so meters per second, I was going to immediately write m/s. I like the better way of saying that. What was that, Michael? Meters over seconds. I'm now in the fractional notation. That can simplify my evaluation. What is my given information? Kilometers per hour, the unit first, and officially kilometers over hours. But it's 105. Where does the 105 show up?
Next to the kilometers.
Why next to the kilometers?
Because that's how you read it. I don't know.
What is the 105 written next to? Kilometers. Okay? It is not written next to hours. You now know that the 105 in your conversion factor had better show up next to kilometers. Okay? That's the meaning behind that. It simplifies your calculations. What's the number that shows up next to hours? 1. If it is any other number than 1, what happens? It is not 105 kilometers per hour anymore. Okay? It changes the meaning of that given information. Is 105 kilometers per hour the same thing as meters per second? So what do we have to do? Convert. Okay? Convert both of them. That's usually where people move. Okay? I don't have the answer. I need to make it to the door, so I'm just going to back up a little bit, and I'm just going to sprint and leap out the door. Does that make sense? Okay. So, Rylan, V, Catherine, Crystal, Michael, Bianca. Does it make sense for me to just back up here and run and jump out the door right now?
Do it.
You guys are horrible people.
Why don't you just try it? Let's see what happens.
If you have
We're supposed to know we don't learn.
determination,
I would bet V's going to be very upset because she'll probably catch a knee to the face. Okay? And I would bet Crystal and Michael are probably, one is probably going to catch a shoulder and the other one's probably going to catch my head. Okay? Bianca's probably like, go for it because I'm just going to sit back and watch this awesome debacle. Okay? We don't jump straight out the door. I can walk forwards. I can then turn corners and I can go to the door slowly. Same thing with a conversion. Stepwise. Do I need to convert both units simultaneously? No. What unit do I want to convert? Whichever one I'm feeling happy about. That's exactly right. Okay? Hours was the first suggestion. I don't want hours. So what needs to happen in my conversion factor? Where does hours need to show up? On the top. Ooh, this is interesting. This is a little bit different than we've done before because we always put that unit down below. Why is it now changing? Because it's about canceling the unit. Ideally, what would I turn the hours to? Okay. Our ideal is seconds. Does anybody know that conversion? Shh. No. Which then means we'll convert the hours to minutes. Do you know that conversion? Yeah. 1 hour is 60 minutes. Minutes to seconds. Okay. 60 minutes was 1 second. Wait, what? Exactly. By putting words to it, it doesn't make sense. What does that need to become? What unit would I now have? No. I would have kilometers over seconds. Is that what I want? No. What do I do? Yes. Kilometers, meters. How do we convert? 10 to the third meters is 1 kilometer, and we now have it.
Beautiful.
I can't quite tell. I'm getting some people being like, I think I totally get this is easy and dumb, and I'm getting some people that I think are understanding, not quite grasping what's happening here. Where are we? Are we good? Okay, then we aren't doing any more of those examples. Percents, we're going to say we're done with those. Volumes, because this is the one I really want to get to. Volume can be measured using distances. Okay, volume is the area, or the, well, not area, it's the volume. Volume is the space within an object. If I have a square object, how do I calculate the volume?
Length times width.
Length times width times height. If I define that volume by measurements, okay, by distances, I can then create a new volume unit. Okay? That is where our volume comes from. So we went through and defined 1 liter as a volume to be the cube 10 centimeters on a side.
Bless you.
Okay? And this is really where I wanted to get, because you all were like, this is totally cool, I get it. Here you go. 498 centimeters cubed. Okay? In each cylinder. What is the displacement of a cylinder in cubic inches? What do we want for an answer?
Cubic inches.
What are we given?
Cubic centimeters.
Okay.
Could you leave it cubed theoretically the entire?
So,
Centimeters to inch. Do you know that?
2.5.
2.54.
I don't accept. 2.54 centimeters is 1 inch, right?
Yeah, and then the cube is one.
Okay, so let's add in the cubed.
Are you supposed to do that?
No, because then we're canceling out the cube.
Okay, well, don't we want to cancel out the cube so I get inches cubed?
Oh, yeah.
That's a trick question.
Yeah, so I think we're good.
I never trusted you.
What part of this slide makes you think that this is a trick question?
Everything.
This is
Honestly, you don't even need to.
What is the issue? What is the issue here?
There you go.
I have to run the 1 inch to 2.54 centimeters 3 times. Okay. This work is now valid. For answers that would show up, 498 divided by 2.54, guaranteed is one of your answer choices on the multiple choice. Which is wrong. Because in that, all you did was say, oh, well, it's cubed, so I'm just going to draw a cube there, and now the units line up. You aren't just drawing a cube there. You have to cube the whole thing. If you aren't comfortable with drawing in the cube and cubing the whole thing, there's the longhand version of this. What would your unit be after that single calculation? Nope.
Oh, that one. Oh,
Yep.
that would be in inches.
That would not be in inches.
Centimeters cubed inches over
It would be centimeters cubed times inches over centimeters.
So it won't be centimeters squared yet.
It would be centimeters squared times inches. The centimeters cancel 1. Okay? So that didn't finalize it and get it all the way to inches. So what can I do? Do it again.
Another one.
And again. Watch out for your volume conversions. Okay.
So that, like,
So with that, unfortunately, we're done.